Hello and welcome to lesson number 5 in Unit 0 of our grade 10 academic math class. This is simplifying polynomials and the distributive property. So we need to start by talking about what polynomials are. Polynomials are gatherings of terms. So a polynomial, like a monomial, is one term, a binomial is two terms, a trinomial is three terms, and then after that, with 4 or 5, etc., they just call them polynomials rather than putting a little prefix in front of them. So polynomial is just a gathering of terms. In this case, when we're talking about simplifying them, what we're talking about is gathering together the terms that are alike. So you don't have to write this down, but just as an illustration, simplifying a polynomial might be just having something like 3x plus 4x's and gathering those together to give you 7x. That's the act of simplifying. The distributive property, on the other hand, has to do with what happens when you are multiplying polynomials together. So when you're multiplying polynomials, essentially what that means is you are multiplying one term by another term, either 1 or 2 or 3 or 2 terms by 2 terms or 3 terms by 3 terms or 2 terms or 1 term. Lots of different combinations that we can get to there. But I do want to point out sort of a few strategies for doing this distribution, following that by then simplifying it, since that's sort of a common pairing in math. So let's look at this first example, and I've already written some stuff down, so if this is a lot of writing, maybe hit a pause here so we can just you can look at it and listen to me rather than trying to copy while I'm talking. So maybe take a second, hit pause, come on back when you've got it copied out. Actually, maybe I'll put the first 2 of them up here so you can just copy both of those and get them up. So let's hit a pause, do a copy, come on back, and I'll talk you through what's happening in these 2 examples. Okay, you're back. So in our first example, we have 3x times negative 5xy squared times negative 3z. So in terms of the big picture here, what I wanted to point out was that 3x is a monomial. It's a single term. Minus 5xy squared is a monomial, and minus 3z also a monomial. And when you're multiplying one term by one term by one term, as if you're multiplying 1 by 1 by 1, you should have one term as the result. And you're going to see how that works out in this particular question, and that it is true. So in terms of a strategy here, what I like to do in questions like this, where there are sort of not a lot of moving pieces, but maybe having a strategy is better than not having a strategy, I like to start by multiplying all of the coefficients together. So in this case, that's 3 times minus 5 times minus 3. Again, I've rewritten them here without doing the multiplication yet. Again, just for the purposes of your notes. I then go on to multiply together all of the x components. That third monomial doesn't have one. And finally, I multiply all of the y components together. Again, there's only one of them. And I guess extra lastly, I'm going to multiply the z with all the other z components. But there isn't any. There's just one. So as you can see here, I've written down, I'm talking about this step here, we've got 3 times negative 5 times negative 3. That's going to give us 45. X times x is going to give us x squared. And as the y squared and z were not multiplied by anything, we just kind of rewrite them as they are. And what you'll notice is that 45x squared y squared z is indeed a single term. Yes, it has lots of components. It has a coefficient, the 45. It has 3 different variables in it, but it is still a single entity, which is something you know in the fact that there's no pluses or minuses anywhere in it. It really just is a single thing. So let's have a look at the second example. Same idea here, except this time we're multiplying a monomial by a trinomial. So in terms of thinking through it, one term multiplied by 3 terms, as in 1 times 3, should result in 3 terms in our final answer. Let's see if this is true. So again, in this case, because there's 3 different pieces, what I'm suggesting is the first thing we do is multiply the monomial by the first term. And I like to do this sort of on the fly in my head. So following the same structure as before, negative 2 times 3 gives us our negative 6. Y times y squared gives us our y cubed. And again, just to recap that, I'm multiplying this whole term by this whole term here. And I have my first term completed. Then I'm going to recommend that we go on to the second one. So now we do negative 2y times negative 4y. So negative 2 times negative 4 gives us a plus 8, and y times y gives us a y squared. Second term complete. Lastly, we are going to multiply negative 2y by the last term, which is plus 5. Negative 2 times plus 5 gives us negative 10, and y times no variable there at all. We're just going to have the y left. And what you'll notice, 1, 2, 3, we end up with 3 terms at the end. That's a trinomial as we predicted it would work. So that's great. Let's try this one over here. This is another copy out, and again, it's just complicated. So again, maybe hit pause here and copy it out, and then I'll talk through it with you. Okay, you're back. You've got it copied out. What we have here, interestingly, are two sets of monomials being multiplied by binomials. You'll know that this is being multiplied because you can see here between the negative 4x and the bracketed x minus 3y, there's no plus or minus, so that's implicit multiplication. And you'll see that same thing over here, minus 2x times 3y plus 5x in brackets. How do we proceed with this? I'm going to distribute each of those monomials into their respective binomials, doing first terms first and then the second. So let's start with minus 4x times x. That's going to give us minus 4, and then minus 4x, and then x times x rather gives us our x squared. Moving along, we now have minus 4x times minus 3y, so minus 4 times minus 3 is a plus 12. There's one x and there's one y, so we're going to have xy there. In the next set of monomial-binomial multiplication, we are going to, again, go from minus 2x times 3y. So minus 2 times 3 is minus 6. You have an x and you have a y. So we have xy. And now, grand finale, we are going to multiply minus 2x by plus 5x. So minus 2 times 5 is minus 10. X times x gives us x squared. Now, a monomial times a binomial is one term times two terms. So we should have two terms, and we have that here, 1, 2. And in that second monomial times a binomial, 1 times 2 should give us 2 terms. We see that there should be 4 in total, and that's what we arrived at. So we're doing great. The trick to this one is that now there is one additional step because we have some terms that are alike. For example, we have, I'm going to run out of colors here. Let's go to hot pink, I guess. We have a minus 4x squared and a minus 10x squared. So combined, minus 4 minus another 10, we have minus 14x squared. Again, think of x squared as an entity that we have minus 4 of or minus 10 of, and when we combine them, it's like combining integers. It doesn't change the x squared, it just changes the amount of them that we have. And we also have plus 12xy and minus 6xy. So we need to simplify how many xy's we have. We have 12 of them, we take away 6, we're left with 6xy. So this idea of knowing how many terms you should end up with after you're done distributing, which is sort of just another way of saying multiplying, is a really good strategy, so you know you didn't leave a term behind, but then we also need to simplify. So your final answer might not have 4 terms because we simplified, and that makes sense. That's totally fine. So now we're going to move into expanding and simplifying polynomials using the distributive property with things other than monomials. What you'll notice in about these first 3 examples that it was always a single term multiplied by a double, or a single term multiplied by a single, or a single term multiplied by a triple. How does it work if you're going to be multiplying out something other than monomials? That's what we're going to look at. So I'm just going to do the first example here. Or I guess look at the first example. Again, maybe take a second and sort of copy down those last 2 lines, and we'll talk about what it means. So hit pause here, copy it down, come on back when you're done, and I'll explain what's going on. Okay, you're back. If we look at that first binomial, x plus 5, in order to distribute, which is multiply the first term, the binomial, by the second term, the binomial, we have to make sure each part is multiplied, each part in the first binomial is multiplied by each part in the second binomial. So I've written this out in a way that's longer than I would expect you to do it once you understand what we're doing, but just for the sake of understanding it better, we're going to be multiplying x by x minus 3. Essentially, we're saying here, our first term is going to be multiplied by this entire binomial, and that's what you see happening here. And then you have the plus 5 being multiplied by, again, that binomial in its entirety, which you see rewritten here. Now this is looking a little more familiar to that last example we did above, where you have a monomial multiplied by a binomial, but twice. So you have, in this case, let me change up my color scheme here, you have x times x, which gives us x squared, x times minus 3, minus 3x. In the second monomial-binomial distribution, 5 times x gives us 5x, and 5 times negative 3 gives us negative 15. So we've completed our distribution, the multiplication piece. Now we need to gather like terms, and there are just a couple like terms in here. We have minus 3x's plus 5x's. Combined is going to give us 2x's. So that's how we go about multiplying a binomial by a binomial. Let's move along and have a look at another one here. So we're going to work it through. We have x minus 6 times x plus 6. we're going to be doing the same thing. We're going to get that first x multiplied by the entire second binomial and that minus 6 multiplied by the entire second binomial. So I'm not going to write it out in quite as protracted a way. Instead, I'm just going to redraw in these lines as I do them. So first off, I'm going to take x times x, and that's going to give me x squared. That's the first term times the first term. Then we're going to do that x times the last term. So x times plus 6 is plus 6x. Next, I'm on to the second half of that first binomial, minus 6 times x, so that's minus 6x. And now lastly, the minus 6 times the plus 6, which is minus 36. So I've got my 4 terms, 1, 2, 3, 4, that's sounding great. I'm going to combine the terms that are alike, these two guys right here. We have x squared plus 6x minus 6x, results in there being no x's at all. So we just have x squared minus 36. That is the end result of our binomial expansion. Now, we're going to squeeze one more out in here, and this is x minus 3 all squared. Now, your temptation is going to be to just square the first thing and just square the second thing and call it a day. But that is not correct. And the reason that's not correct is that we haven't taken into account that the middle terms need to be multiplied together. I'll show you what that means. So I'm going to just change this because I don't want you to write down something that's incorrect. This does not equal that, and I'll show you why. Let's start by rewriting x minus 3 all squared as x minus 3 and x minus 3. We have two binomials being multiplied together, and we are going to expand those out. So I am going to multiply the first term by the first term. That's going to give me an x squared. I'm going to multiply the first term by the last term. That's minus 3x. Then now we're on to that minus 3 in the first bracket. The minus 3 times the x is minus 3x. And then the minus 3 times the minus 3 gives us plus 9. So it's not that our first answer was like radically or crazily off. In fact, there are a couple of common pieces. Yes, there is an x squared. Yes, there is a plus 9. But the piece that got missed was, over the course of this expansion, these ones out here. We missed these two that resulted in the minus 3 and the minus 3. Those happen to be like terms, so when we combine those, we end up with x squared minus 6x plus 9. So that is a binomial expansion, two terms being multiplied by two terms. When you come back in the second half of the video, we're going to crank through just a couple more examples here and sort of one more of an application style question, and then you'll be off to the homework. So we'll see you in part 2.